So averages this is probably a formula that you're familiar with. The average of some numbers is the sum of the numbers. You add all of them together, and you divide that by the number of numbers you just added. So if you have two numbers, let's say 3 and 5, you add them together. That gives you 8, and you divide it by the number of numbers. 8 divided by 2, the average of 3 and 5 is 4. So the GRE does expect you to have this memorized. The average is also known as the arithmetic mean. And it's arithmetic because that's the adjective form. Arithmetic is the noun. Arithmetic mean. So you are expected to have this memorized. If this is old news, of course, you already have it memorized. But if it's been a long time since you've done this, add this to your list of things that you need to have in your head by test day. So a good example of a question on the lower end and would likely appear in a quantitative comparison rather than in a problem solving or numeric entry problem. What's the average of 3, 7, 0, and minus 2? So you add the numbers together, 3 plus 7 plus, and just because 0 doesn't have any value, positive or negative, you do still need to include it because it's one of the numbers, and it will bring the average down. Plus minus 2. We had 4 numbers there because we do include the 0. And so 3 plus 7 is 10, minus 2 is 8. In the numerator, 4 in the denominator, that equals 2. Note that if you did leave the 0 out, it would not come out the same way. So if you did 3 plus 7 minus 2 divided by 3 numbers, 3 plus 7 is 10, minus 2 is 8, numerator stays the same, the denominator is not the same. So it's not okay just to leave 0 out just because it's 0. That's discrimination or something. No, I'm kidding. But you count all the numbers even if it looks like it's not going to have an effect. So again, we always do the number of numbers. There are 4 numbers, so A plus B plus C plus D, and so it's always divided by 4. The sum of the terms is sometimes helpful independently in these average questions, particularly if they leave one of these as a variable. You'll see what I mean as you do some of your practice problems in your homework. And so one of the things that you can also do, so if the average equals the sum of numbers divided by the number of numbers, that also means that the sum is equal to the average times the number of numbers. And so sometimes this format of the equation will actually be the one that ends up being much more useful. So 4 numbers, the sum of the terms we already established was 8. 10 minus 2 is 8, and the sum divided by the number was 2. Because we got 8 over 4 equals 2. So this is a more likely problem that you might get on the GRE, and of course this one is actually taken from our vast treasury of problems. So the average, aka arithmetic mean, I told you that term gets used, of a set of 5 distinct positive integers is 20. What is the greatest possible value of the largest of these numbers? So we don't know what the numbers are, but we know that they're distinct. So we can use variables for all of them, and these distinct variables will stay separate. So we know, so if we do A plus B plus C plus D plus E, that's 5 variables for 5 numbers. And we know that the average of those 5 numbers is 20. So if we add those 5 numbers up, divide by 5, that equals 20. Okay, so this is what I was referring to earlier, how the average formula may be more useful in another form. We actually multiply both sides times 5. We end up with A plus B plus C plus D plus E equals 100. Now, we don't actually need to know what all of the numbers are. We just need to know what the biggest one is. So so the greatest possible value of the largest number, let's just say E is the biggest one. In order for E to be as big as possible, and for the average to be 20, the other numbers need to be as low as possible. The lower these guys are, the bigger this one can be, and still have their sum equal to 100. So The restrictions on what those other four numbers are actually in the problem. They need to be distinct positive integers, so we can't just say it's 1 plus 1 plus 1 plus 1, okay? Because those are not distinct. Nor can we have a be negative 10 because they need to be positive. So, a plus b plus c plus d plus e equals 100. We want these to be as low as possible. The lowest positive integer is 1, but we can't use 1 again, otherwise it wouldn't be distinct. So b needs to be 2. Well, I mean, it doesn't need to be b, but it needs to be the next, one of the other remaining 3 variables needs to be the next lowest positive integer, which is 2. We may as well pick on b since it was next. C needs to be the next lowest in turn, and D needs to be the next lowest after that. E is our mystery guest. Those still add up to 100. So 4 plus 3 is 7, plus 2 is 9, plus 1 is 10. So E plus 10 equals 100. E therefore equals 90. So we would enter, key in, or transfer, if we were using the calculator, we would transfer 90 into the numeric entry box. The largest possible value of the largest number is 90. See, so I mean, the average formula actually can be used in a number of ways. It's not just going to be, hey, here's 5 numbers, come up with the average. They may ask you to fill in for a missing variable, or determine what the largest or smallest possible value of a certain one is, or maybe more than one. So be prepared to use the average formula in ways that you might not have expected. So weighted averages are a little bit different. When you have 2 or more groups and they have different concentrations of them, okay, you have to do a weighted average, not a straight up arithmetic mean. So you should never average averages. So this is the weighted average formula. Let me actually bring up the example question so you see what's going on here. So in a math class, if there are 10 boys with an average height of 60 inches and 8 girls with an average height of 50 inches, what is the average height of the class? So what you can't do is, since the boys' average height is 60 and the girls' average height is 50, you can't just average 60 and 50 together, which would be 55 inches. The reason you can't is that there are more boys than girls. So the average of the class should actually be slightly higher than the average of just the 2 numbers. It should be closer to the 60 end of things because the weight, that's why it's called a weighted average, the weight should be more towards the group that there's more of, because they will make the average skew in that direction. So you could, I suppose, in theory, put in your calculator, 10 boys at 60, 60 plus 60 plus 60, blah, 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 all the way to the end. And then add in the girls, plus 50, plus 50, plus 50. But that's a pain. This is where the average formula comes in handy. So you use the number of people in, or number of whatevers in the first group, the first average. So that's 10 boys, times their average, which is 60. I'm just going to delete that because that's sloppy. 10 times 60. And then we add in the number of people, and in this case it is people. The girls, there are 8 girls times 50. And we divide that by the total number of people in the class, which is 18. So in this case then, 60 times 10 equals 600. And then 8 times 50 is 400, and it's still over 18. So 1,000 over 18, and it ends up being 55 point something. So I didn't put it into the calculator. This is where you would actually use it, use your calculator to figure it out, assuming it was numeric entry. If it was multiple choice, you'd look for the answer there. And note that if there were more than 2 groups, you would just continue along the same lines. So if there were a third group, it would be plus the number in C times the average of C. And then you would also add in the number in C down here. So you could do a weighted average of any number of groups of things. You just can't average the averages. Now, the only time you could average the averages, I guess I should point this out in case you were wondering, if I say never average averages, if there were the same number of boys and girls, then you could average the 2. But if they're different, you need to use the weighted average. Ta-da! And in fact, actually, I should mention, in problems where they're in a problem-solving question where they give you multiple choice answers, you could have crossed off any answer choices that were lower than 55 inches. So if you were you couldn't figure out the problem the rest of the way, you didn't remember the weighted average formula, you would still know that since there are more boys than girls, the average height of the class needs to be higher than the strict average of 50 and 60. So you would at least be able to improve your odds of guessing.